Hello, Pre-Calculus. Today we are going to start into Chapter 4. Lesson 4.1 traditionally takes me a little bit more than a day. I can get a lot of it done in the first period, but that usually takes me some of a second period. So I'm going to keep an eye on the time. I'm going to record an appropriate amount for a period or a little less, and then hopefully, I believe this is going to be Friday, January 22nd's lesson, and then hopefully I will be able to be at school Monday to finish the lesson with you. Otherwise, you will have another video. So, we are talking about angles and their measures, as you see. The first part of our lesson works with talking about degrees versus something called DMS. Okay, so a degree, represented by the symbol, and you guys are familiar with the traditional little bubble, is a unit of angular measure up to 1/180th of a straight angle. So a straight angle being a straight line, you guys realize a straight line measures 180 degrees, and so that description is saying that a degree is 1/180th of that angle. Okay. Now, in the DMS, which stands for degree, minute, second system of angular measure, each degree is divided into 60 minutes, which is denoted by, and that is a singular, what I would call tick mark or like an apostrophe. And each minute is divided into 60 seconds, and that uses a double set of tick marks, or more like a quotation mark. In these first set of examples, we're going to practice going back and forth between the two. So, in example A, we are asked to take 37.425 degrees and convert it to DMS. So we're going to convert it to degrees, minutes, and seconds. Hopefully, what you can notice right now is how many degrees it is, because that is right there in front of us, and 37.425 degrees is how many whole degrees. And recognize that is 37 degrees. So we actually already have the first part of our answer as 37 degrees. And the rest of this is about converting the decimal portion, which is a portion of a degree, into minutes and seconds. So if you look at the piece that remains that we have to convert, it is 0.425 degrees. And we're going to start by converting that to minutes. And you will notice each degree is divided into 60 minutes. Well, this is a portion of a degree, and so in order to change this to minutes, we have to use the fact that 1 degree is 60 minutes. If we make this a fraction, and we think about what I call dimensional analysis, you've done it in math classes, you've done it in science classes, but where we're trying to cancel units, 0.425 degrees over 1, and then you're multiplying by either 60 minutes over 1 degree or 1 degree over 60 minutes, because 1 degree is equal to 60 minutes. And so in this case, we're going to multiply by 60 minutes over 1 degree, all because we are trying to get our degrees to cancel. And so those labels of degrees cancel, and so when we multiply 0.425 times 60, that is going to get us to our minutes. So 0.425 times 60, your calculator hopefully says 25.5. And notice what label goes on here is minutes. Now, like last time, we're looking for whole number answers. And so you will notice right there, 25.5. Well, the 25 minutes is your whole minutes that goes for your answer. So back here, my answer, I'm going to put 25 minutes. And then we are left with this 0.5 minutes. Now, if I ask you 0.5 minutes, how many seconds that is, the math is very doable there, I hope you realize. But if I show you the actual math of how it works, okay, we're taking 0.5 minutes, I'm going to make it a fraction over 1, and I'm trying to convert it to seconds. We know that 1 minute is 60 seconds. So I can either multiply by 1 minute over 60 seconds or 60 seconds over 1 minute. Again, I want my minutes to cancel, so I'm going to put 1 minute on top on bottom, 60 seconds on top. And when you look at this, notice first of all, my minutes will cancel because they're on the diagonal. And then we have 0.5 times 60. And 0.5 times 60, half of 60 is 30. And that will be 30 seconds. And that is the final portion of your answer. So you're always taking your whole number portion and putting it in your answer. And then the decimal part works to become the next part of your answer. So 37.425 degrees is 37 degrees, 25 minutes, and 30 seconds. You sometimes hear that in locations when we think about degrees and latitude, longitude, that it's so many degrees, minutes, and seconds. This is what we're talking about here. Okay, let's practice one more, get the feel for it. This time we're converting 157.892 degrees to degrees, minutes, seconds. So 157 and 892 thousandths degrees. First part you can already distinguish. How many degrees do we have? And we have 157 degrees as part of our answer. Now we're going to look at the decimal portion, which is the 892 thousandths degrees. I'm going to put it a fraction over 1. And I'm trying to convert it to minutes. What do you know about the relationship between degrees and minutes? 1 degree is 60 minutes. So I'm going to make it a fraction. 60 minutes over 1 degree, because I want my degrees to cancel. Take the calculator. 892 thousandths times 60. The calculator tells you 53.52, and this would be minutes. Again, we want the whole number portion for our answer. So we're going to take 53 and put it back in our answer. So we have 157 degrees and 53 minutes so far. And then we're going to take the decimal portion and we're going to turn that into seconds. So 52 hundredths minutes, 0.52 minutes, times, and again, we know 1 minute is 60 seconds. So I'm going to do 60 seconds over 1 minute. My minutes labels will cancel. And so 60 times the decimal 0.52 works out to be 31.2 seconds. And at this point, we go ahead and put that decimal in our answer because there's no further breakdown to do. So final answer of 157 degrees, 53 minutes, and 31.2 seconds. Okay, so on those two examples, we are converting from degrees to DMS, degree, minute, seconds. And basically in both cases, notice we were taking the pieces and we were multiplying by 60. Now we need to go backwards. We're being given a measurement that is in DMS, degrees, minutes, seconds, and we're going to take that to degrees. Like last time, you know the beginning part of your answer. It's 42 degrees, 24 minutes, 36 seconds. Well, I know without doing any math that this is going to be 42 point some degrees. Last time, we were taking pieces and multiplying by 60, correct? So if we're going the other way, logic says we're going to take this and we are going to be dividing by 60. Now, there is one slight catch when we get to seconds, so hang with me before you take off, but the idea is the same. And there's a couple different ways we can do this, but here's what I'm going to teach. First of all, we have the 42 degrees, yes? What do you know about minutes in terms of degrees? There's 24 minutes, and we know that 1 degree is 60 minutes. So I'm going to take the 24 minutes, and this time I'm going to divide. Okay. And that right there, when I do the 24 minutes and dividing by the 60 minutes, that is going to give me degrees. Now, you can go ahead and do that part. The 24 divided by 60 will give you 0.4 if you wish. And then we also have to worry about the seconds. And we have 36 seconds. Now, we already talked about the fact that 1 degree is 60 minutes. What do you know about seconds? If 1 degree is 60 minutes, and 60 minutes, and each of those minutes is 60 seconds, then we're not just dividing by 60 here. We're dividing by what I would say is 60 times 60. And what is 60 times 60? 60 times 60 is 3,600. So we're going to be dividing by 3,600. And we do 36 divided by 3,600. That's going to give me the last part of my degrees. If you do that individually, it's 0.01. So if you add 42 degrees plus 0.4 plus 0.01, you end up with 42.41 degrees. Now, unfortunately, I'm not in class to show you this on the calculator, but honestly, on the calculator, you can take that whole statement I have written there of 42 plus 24 divided by 60 plus 36 divided by 3,600, and it will, in one big step, give you that 42.41 degrees. So you don't have to go through and do this individually. On C, it wouldn't have been bad to do it individually. On D, I'll show you why it's easiest to just do it all at once, or again, you can always go back on the calculator and grab the other pieces and add them, I guess, as well. So let's try D. 125 degrees, 56 minutes, and 35 seconds. We're going to go to degrees. So if you look at the beginning, the one thing I do know is that this is going to be 125 point some degrees. So if I get something other than that on my calculator, I know I've made a mistake. So I know I'm going to have 125 degrees plus 56 minutes to see what portion of a degree that is. We're going to take 56 minutes and divide by 60. Now, if you go ahead and divide that on the calculator, I believe it's 0.93 and the 3 is repeating. Do not round it because that will change your answer. You're going to want to leave it the long decimal. And then that was minutes. We have 35 seconds. Well, what do we know about seconds? In a degree, there's going to be not just 60, but 60 minutes in a degree, 60 seconds in each minute, so 60 times 60. Or in other words, we're going to do 35 divided by 3,600. Now, for 35 divided by 3,600, I have written down as 0.00972, and the 2 is repeating. And this is where I would say, if you've done those pieces individually, take your calculator, 125, go back and grab the plus the 0.93 repeating, and then go back and grab the 0.00972 repeating. Or enter it all in one big calculation, and it's 125.943 degrees. Obviously, that is a rounded answer, and I can't remember if the book says to round to, that would be thousandths, or if I just chose 3 decimal places, but either way, that is the answer I have there. Okay, so that is just a little bit about degrees. Let's move on and talk to more of what this chapter is built on, which is the relationship between degrees and radians. If you're sitting in my classroom in your seat watching this video, you know off to your left is that big circle, what I call the unit circle. And that's where we start talking about in this chapter. Luckily, this lesson's not a big focus on it, so it's not a huge deal that I'm not there to do this in person. But if you look at a circle, I would like to think that you know around the circle is 360 degrees. Okay, So around that circle is 360 degrees. Equivalent to going around that circle and being 360 degrees is, in radians, it is 2 pi radians. So, and again, I know that's new. We'll talk about, as you look at that board, if you're looking at it now, the radians on there is what you will see labeled. And if I remember, I will get some degrees written on there in marker to help you out. But the idea is, if 360 degrees is equivalent to 2 pi radians, then that can also be reduced to the fact that 180 degrees is equivalent to pi radians. So if you think about 180 degrees, so like a straight angle, and this would be like if you're looking up there, you're starting at 3 o'clock. So 3 o'clock, counterclockwise over to 9 o'clock is 180 degrees. It's also pi radians. And so our conversion factors that we use here are the fact to go from degrees to radians. You can multiply by pi over 180 because you're trying to go to radians and cancel out degrees. If you're trying to go the other way, you're trying to get to degrees, so you're trying to convert what's already radians to degrees, and you want the radians to cancel out, you put the pi on bottom, and it's 180 times pi. Okay, so we'll work with those throughout this chapter. Let's look at some basic conversions here. First question says, how many radians are in 90 degrees? Now, I'll be honest, you could use some logic based on the fact that I said 2 pi is all the way around the circle and is 360. We talked about half the way around the circle is 180 or pi. So you can figure out what 90 degrees is at that point. But we can also use our conversion factors. We're trying to take 90 degrees. And we're trying to go 2 radians. So if you look up top to go 2 radians, we're going to multiply by pi over 180. So if I multiply 90 degrees by pi over 180, you can think of that as 90 pi over 180. But also recognize the big simplification. 90 and 180 divide to be 1/2. So I have 1 pi over 2, which is more simply written as pi over 2. And this would be pi over 2 radians. You will learn real quick in this chapter, if something is not labeled, it is radians. If it's degrees, it will have a degree mark. Okay, so right there, basic introduction. Notice it's using fractions though, so it's already using skills that are older skills to you, definitely. Okay, moving on. How many radians are in 250 degrees? And so we're taking 250 degrees and converting it to radians. To convert it to radians, I'm going to multiply, again, like it said up above, to go from degrees to radians. We multiply by pi over 180. Now, as I start to multiply, yes, you can go ahead and think about it as 250 pi over 180. I would also like to notice, what's an easy cancel there? An easy cancel trick is that they both have a 0, right? So if we basically divide both of them by 10, you're canceling a 0. And so now that puts me at 25 times pi. So 25 pi over 18. And of course that 25 pi over 18, you'd want to check for simplifying. But 25 and 18 do not have any common factors. And so this again, of course, is radians. Typical radians, I won't say all the time, but a lot of the time you leave it in the form of pi, which means you leave the pi there in the fraction. Okay, let's reverse. This time it's how many degrees are in pi over 3 radians. So we're going to start with the given pi over 3, and we're trying to go 2 degrees. So to convert from radians to degrees, look up above, and you'll notice it says to multiply by 180 over pi. I think whatever I'm trying to get to is what's on top of that fraction. So since I'm trying to get to degrees, I have 180 on top. Look at some basic when I multiply pi over 3 times 180 over pi. Notice the obvious piece there to me is that a pi on top and a pi on bottom will cancel. And then you can keep multiplying as is. It's 180 over 3, and you can write it as 180 over 3 if you want. However, I'm also just fine if you go ahead and say, oh, well, I know 180 over 3 divided by 3 is 60. So this would be 60. 60 what? And this would be degrees. And you need to make sure you get a label on for degrees always. Okay. Example D. Okay, sorry, we're starting on D. Hopefully that wasn't too weird. I just had to pause my video because I realized example F was not showing down at the bottom. Okay, so there may have been a weird glitch there. But example D, how many degrees are in 5 pi over 18 radians? So this time, I'm trying to go 2 degrees. So of course I'm going to start with 5 pi over 18. To get it 2 degrees, I'm going to multiply by the one that has degrees on top. So 180 over pi. And I, of course, like to do some canceling as much as I can. The obvious piece of canceling is that pi is going to cancel. So I'm going to cancel a pi with a pi. And then as you look, I have 180 and 18. 180 and 18 will both divide by 18. 18 divided by 18 will be 1. 180 divided by 18 will become 10. And so now, if we multiply, we have 5 times 10 over 1 times 1. Or in other words, 50 degrees. If you would have preferred to multiply 5 times 180 over 18 and then reduced it, you could. I just think the math is a little more difficult that way. Okay, E. Convert 25.5 degrees to radians. So, this time, we're going 2 radians, starting with degrees. So, of course, I'm going to start with 25.5 degrees. And to get to radians, I'm multiplying by pi over 180. Now this one's a little different because it is in decimals, so I'm just going to multiply across. And then I have 25.5 pi over 180. Now, realize this is not an appropriate answer because I have a decimal within my fraction. And of course, that is not allowed. So, options to get rid of a decimal place. And there's not going to be just one right way. I mean, traditionally what I'm going to say with to move a decimal 1 to the right, traditionally you should say we're going to multiply by 10. And so I'm going to multiply by 10 over 10 here to move my decimal to the right. Now, if someone else said, oh, well, I just multiplied by 2 because that would take care of the half, that would work too. Okay, there's options here. So one way or another, multiply by something and get rid of the decimal. So when I multiply by 10, I'm going to come up with 255 pi over 1800. And at this point, your job is to reduce. You can look for factors that will reduce. They both divide by 5. They're going to go probably more than 1 5. There's a couple of things they divide by. I can't remember what right offhand. Looks like they both divide by 5 and 3. Or in other words, they both divide by 15. Now, in all honesty, you can't use it with the pi. But if you do 255 over 1800 on your calculator, and then you go into the math menu and you go to number 1 and turn it to a fraction, it will give you the simplified form. In that, this becomes 17 over 20, still with the pi, so I'm going to say 17 pi over 120. Hopefully I didn't just say 20 there and I did say 120. Okay, so if you want help with that calculator technique, grab me in class, ask me in class sometime. I'll be more than willing to help. But I just did the 255 over 1800 on my calculator, and I just got a decimal there. Then I went into my math menu button, and I hit just right there, number 1, where it says 2 fraction. I picked that, and it automatically gave me the 17 over 120. Okay, one last more here, and that is converting 2.5 radians to degrees. So notice there I'm trying to go 2 degrees. Notice this 2.5 that we're given is radians. It's not your typical radians because typical radians would be expressed using a pi. So that does make it a little bit different. But to go 2 degrees, we're still going to multiply by 180 over pi. If you look at 2.5 times 180, that is 450 over pi. Now, because I am trying to express my answers in degrees, I will not be leaving my answer in this form. 450 over pi is more of a radian type answer, but in degrees I'm looking for decimals. So if I take 450 and I divide by pi on my calculator, which pi is the second function of your exponent button, which is over on the right side of your calculator, and I get the decimal 143.2394488. I'm going to round that to hundredths and say 143 and 24 hundredths degrees. Again, on any of this that you run into questions on, misunderstandings, please ask me in class. Okay, I think I'm at 27 and a half minutes. I'm going to go ahead and try and do I want to do one more in the back or do I want to save it? I think we'll go ahead and try one more example at the front page of the back. So go ahead and turn to the back. And we're going to talk about this arc length formula. So, first of all, it talks about a central angle. A central angle is the angle made at the center of the circle. So, we all know this is a bad idea, but I'm going to freehand a circle over here. Okay, you got to see attempt 1. Not horrible. Okay, so a central angle, the idea of a central angle is using the center of the circle, an angle that goes from the center of the circle. So the central angle is that inside amount, whatever that might happen to be. When we talk about a central angle, that angle is usually defined as theta. Theta being Greek letter, looks like a circle with a horizontal line through it. So that is theta when you hear me talk about it. And then the arc length S. So you'll notice here it talks about S. S stands for arc length. And arc length is the length of the curved partition of the circle. So if you look at my picture over here, we had that central angle, and that central angle was right in here. The S is this distance right here, the distance on the curved arc length. So that would be S. Okay, we have an arc length formula that we're being provided. Arc length formula, S equals R theta. Notice what it does say, where R is the radius and theta is the angle in radian form. That will be your big catch there. Theta must be in radian form. Okay? So, let's do this one example, and then we will save the rest for when I am with you in class. Hopefully, my plan is that this will be Friday's notes, and so then I will be with you in class on Monday, hopefully. So, example, find the perimeter of a 60-degree slice of a large 7-inch radius pizza. Okay, so we have a pizza, which means I get to draw another circle. I'm going to draw a bigger circle this time, so I have room to work there. And what do we know? We need the perimeter of a 60-degree slice of a large 7-inch radius pizza. So here's my center of my circle. There's one side, and there's my other side. There's my approximation of a 60-degree slice of pizza. Not saying it's perfect, but that's my approximation. So I am, okay, sorry, that drew rather weird there. Okay, so I'm saying that is a 60-degree slice of pizza. Has a 7-inch radius. So what do I already know about two sides of that piece of pizza? I know that this is 7 inches and this is 7 inches. What is the piece I don't know? Or this side I don't know? And I don't know this curved piece. Okay, obviously this is where our arc length formula comes into play, because arc length is going to allow me to find the length of that arc that I traced in red. So let's grab our formula. S equals R theta, and that's going to find that arc length right there. So S equals R, stands for radius, which is 7 inches, times theta, which is our angle. Now, is anyone working ahead of me? Did you catch the catch? Our angle is what? 60 degrees. But what did the formula say up above? Where theta is the angle in radian form. So you need to take 60 degrees and convert it to radians before you continue. If I take 60 and convert it to radians, remember from the front page that we're going to be multiplying by pi over 180. 60 times pi over 180. 60 pi over 180, but we know 60 over 180 is a third. So this is pi over 3. So I'm going to put pi over 3 in my formula. And again, that is to find the arc length. 7 times pi over 3. Typical form would be to leave it 7 pi over 3. Because I'm trying to find perimeter, I'm going to go with a decimal equivalency. And decimal equivalency is approximately 7.330382858 is what my calculator just said. So I'm going to go with approximately 7.3. So that's S right there. Now, what did the question ask? It asked me to find the perimeter. Okay, final step. How do we find perimeter? Perimeter of the slice of pizza. So we already had the radius on the two straight sides. So 7 plus 7 plus what I would call the crust of the pizza, the curved side. And how long is my crust going to be? That's that S I just found. So 7.3. 7 plus 7 plus 7.3 is going to end up being approximately 21.3, what's my units? Inches. Okay, I am at 34 minutes, almost 35 by the time I get done here, so this is a good stopping point. Notice I've already written the homework down at the bottom corner. The homework for this entire lesson will be page 325, 2 through 42 evens, 45, 50, and 51. Now, I still have to teach the other portion of this lesson though. So use any remaining time that you have in class right now to start working on the homework. The lesson is not due the next day in class. It will be due the day after I finish teaching the lesson. So if you're watching this on Friday, I will finish teaching on Monday, and this homework would likely be due on Tuesday. Keep in mind, those dates could change if plans change between now and then. Have a great day and get some work done. Bye.